Here we go. Let's launch our screens again. Here we go. So the product rule, you've seen it, I'm sure. It's not the university stuff, it's really high school stuff. But here the worst thing is that you need a lot of practice, otherwise you get really rusty and you cannot do it fast. Like, you can still do it, but our goal is to do it like that, because on the micro exam you will not have time to recall how do I take a derivative. You'll have to think micro. Okay, so that's why we need to revise the product rule, the chain rule, the how to derive fractions, and then the more advanced things as inverse function derivative and the implicit function derivative. Okay, so today what is doable to cover is product rule and the rule to derive a fraction, and you'll have big homework. So you actually for that will not need any extra exercises. And if you now wonder, well, are we gonna do a lot of stuff like that in micro? Yes, but for now you really should focus on the math part, because micro, it will get there whenever you need it to get there, and the same about economic growth and macro and econometrics, obviously. Okay, let's get to a product rule. So first let's look at the formula, then I'm going to show you how it works on simple examples, and only then I'll give you time to do this. Okay, so let's check the formula. We have a product of two functions, so the f and g means that there are different functional forms. For example, one is a logarithm and another one is a sine, or one is just 2x and another one is a logarithm. Okay, so what we're supposed to do to get the derivative of a product, it is not a product of derivatives, as you can understand, since we have a formula for that. So we take a derivative of a first function with respect to x multiplied by the second function as it is, and then we add to it the derivative of the second function with respect to x multiplied by the first function as it is. So let's take a simple example here. 5x to the power of 5 times, here I have times, but well, understand, 3x minus 7. Okay, no, what am I doing? Let's call it f of x. And now let's find a derivative of f of x. So here I want us to follow product rule. So that means we have this function that will be red and this part of function that will be green. So this is function f, let's say, and this is function g, let's say. Okay, and let's call this y so we don't confuse all these letters. As always, letters don't matter, we can call them whichever letter, but to just stick to the same notation as on our slides on the left. Okay, perfect. So we're gonna take the derivative of this, then multiply it by this, then add the derivative of the green part multiplied by just the red part. So the red part is our f and the green part is our g from the function on the left. So the derivative here will be 25x to the power of 4 multiplied by the second function as it is, so 3x minus 7, plus the derivative of the second function, which will be just 3, multiplied by let's put these times here, multiplied by 5x to the power of 5. because we don't touch it, so we keep it as it is. We can simplify it, we can work with it a little more, but it does not matter. Just learn how to use the formula. So some of you should tell me, why do we need to use product rule here? We can just rewrite this in black as 15x to the power of 6 minus 35x to the power of 5. Just simply take the derivative of this part and this part. So you see that that will be 15 times 6x to the power of 5 minus 35 times 5x to the power of 4. Yes, that will be right. But I asked you to just use the product rule, so in cases like that, you can expand it and then you can easily calculate the derivative just using these first formulas. But if you cannot expand it, like in this case, for example, well, what do? You have to use product rule. So let's take another not difficult example. Here, x to the power of 8 plus 8 times x to the power of 6 plus 11. So here it already makes a bit more sense to do product rule because expanding will take too long. Again, this is the function this is function y of x. And if I want to calculate its first derivative with respect to x, I'm going to take the derivative of the first times the second, then derivative of the second times the first part. So the derivative of the first part is 8x to the power of 7. I multiply it by x to the power of 6 plus 11. And then I do plus, and the derivative of the second part is x to the power of 6. 6x to the power of 5 times that, well, this is the derivative of the second part, and then times the first part as it is. And obviously here we're not going to simplify anything, whatever, we just leave it this way. So now, I think it's clear. I think you just need to practice more if you forgot or if you've seen it for the first time. Also can happen. And, okay, just take your, 5 minutes. Take your 7 minutes here to complete 5 examples. So using product rule. The first one you can do without product rule, it's much easier, right? But just do it using product rule. Up, up. Okay, cool. So for the first one, what I got without any simplification, okay? But I'm just gonna write it like it is. 1 plus the fraction 1 over x oh, nice, plus minus I said minus, didn't write minus, fraction of 1 over x squared times x squared. Okay, you see, I know you know that this can be simplified, so the second part will just gonna be the same as the minus 1, but as I mentioned, we just need the first step, so we're sure that we're applying the rule correctly. So slide 6, solutions. And so this is more chill part of our course. For now, the derivatives are nice to us. Then what I have is the fraction 1 over x uh, x cubed plus x plus 2x plus 1 ln x. So an issue here, if you are brilliant, still can be that you're forgetting to multiply by the second function. So be careful with that. Okay, then the third one will be 2 times the square root of x plus e to the power of x. Yeah, if I'm writing something wrong, you should tell me something. The second one, this one, this one. Yeah, you're right. Yeah, you're right. Okay. Perfect, yes, because the first derivative of the second part, obviously, applying the formula, we get 3 times x to the power of 3 minus 1. Okay, thank you very much. Yeah, do that. Follow. Okay, this is a hard one. Plus, now here we're gonna have a fraction. Okay, 1, perfect. Then 2 square root of x. If you got here the expression that I was showing you before, it's all good for the derivative of a square root plus e to the power of x times 2x. Yeah. Maybe some of them are coming to something nice. Well, the first one for sure. Okay, don't make another mistake. Yes, 1 over 2 times x to the power of minus 1 over 2 is perfectly fine. I just wanted to simplify it because it's easier for me to type it and faster. Then now we move to the sign, so we have this stuff. Oh, sorry, thought I was typing. Times the fraction again that we're gonna have here 2 over x plus x squared. Then we're gonna get plus minus 2 over x to the power of 3. I don't like it. Why did I get to the power of 3? To the power of 2. Yes. Yeah, to the power of 2. And again here, yes. Here what you could do is not write the x squared in the denominator, but just keep minus 2x to the power of minus 2. then plus 2x, and then all this times the sign. Okay, get it there. And the last is always the ugliest one. So here we have minus 4 over x cubed. Okay, here it is cube. Why is it minus 4? Makes sense. Minus 4x cubed plus 1 times. Okay, here I didn't want to bother. X to the power of minus 0 point. Okay, wait a second. This should be okay. But I have a conversation. Yes, it could also be written as minus x, or minus 4 to the power, minus 4x to the power of minus 3. Thank you for answering. And that was one, right? Okay, I didn't erase much of important stuff. Oh yeah, I actually did. Okay, times x to the power of, again, minus 0.3, that I want to keep like that, and I could certainly just write 1 over x to the power of 0.3 plus 1 here, and then plus, and then minus 0.3 x to the power of minus 1.3 and this times, well, the first parenthesis, you got it, 2x squared plus x. Okay. Thank you. Cool. So that was the product rule. I can see that it's all right with you, so I'm very glad. The thing here is to be very careful. Because, for example, for micro, you will have generally like 3 very big exercises. So you will be given a utility function and then like 10 questions for it, whatever questions. And then you'll have to find the derivative somewhere in the beginning. And if you make a mistake there, the whole thing, so the whole question will be considered wrong. And sometimes it's not a big deal. As I told you, like arithmetics can be not a big deal, but sometimes it changes actually stuff. So for example, you were supposed to get a positive derivative and you got it negative. And then the conclusion that you're making is that the function is decreasing. We'll see about that too. So you see, it can be an issue. All right, but I see the product rule is okay. You do it better than me. I'm glad. Now, how do we deal with fractions? Again, we should just try to divide the stuff by stuff as much as we can, but then there is a certain point where we cannot. Well, for the first one, for example, we still can simplify it without losing almost anything, but never mind. Let's use the formula. So what do we do here? When we see a fraction, and you will see them, first thing we do is we put its to get the derivative. We put its denominator to the power of 2. We raise it to square. Perfect. That's done. Then we deal with the numerator. And the way we deal with the numerator reminds us a little bit of our product rule. except for we don't do plus, we do minus. All right, so perfect. Here, before we do that, I want to show you a couple of examples as the last time, so you get it refreshed. We have y of x that is equal to a fraction, and we have 10x to the power of 8 minus 6x to the power of 7, and here we have 2x. Okay, so we get this, and then I'm asking you, please calculate the first derivative with respect to x, obviously, not to y. As I told you, the first thing that you should do is, without even looking at the numerator denominator, you should raise the denominator to the power of 2. Right? Like, honestly, here we see straight that we can divide both of the elements from the numerator by 2x and get just something that is not a fraction. But well, we're taking a simple example to train the rule. Now here, Now here we have to take the first derivative of the numerator, which will be 18x to the power of 7 minus 42x to the power of 6, and then we multiply this by the denominator as it is, so we say times 2x, and then we do minus, which is important, not plus, the derivative of the denominator, which is very nice here and short, multiplied by times the numerator, so 10x to the power of 8 minus 6x to the power of 7. Cool. Okay, so see, if we simplify it, we'll get something much better, but again, right now the objective is not to simplify, the objective is to just write the correct expression. Another one, last one, and then I leave it to after the 2 to the power of x, after 2x minus 2 times, yes. Yeah, that's times. Why? Because I just applied this thing. I just applied this rule. So I said, now I have to take the derivative of the denominator and multiply it by the numerator. And that's the numerator, right? And that's the derivative of the denominator. All answered? Cool, thank you. Another one. Fraction. Which one should I take? This one. It's nice. 4x to the power of 5 divided by 10 minus 3x. See, it's not very difficult, but what we cannot do here is simplify, so we have to go through the rule of derivation of the fractions. Equals, the first thing first, we raise denominator. 10 minus 3x squared, right? Right. Then we take the derivative of the numerator, which is going to be 20x to the power 4, and then we multiply it, I'm using times, to the denominator, as it is. Then minus, the derivative of the denominator will be minus 3, and we multiply it by the numerator as it is, 4x to the power of 5. Again, simplification can be done whenever we need it. Okay, perfect. So now your turn. I think that this will be the last thing we do, because chain rule requires fresh attention, and we're gonna start with that tomorrow. So tomorrow we're gonna aim at getting to the directional derivative, so getting here. I think we can. And these are your exercises, and I'm giving you, we have 5 ugly things. I'm giving you 7 minutes again, so at 48 we're gonna check. I should stop sharing that and now start sharing again the whole screen. Okay, so here we go. This is the first answer. Actually, yeah. So we could simplify straight here, right? But again, we changed the rules, so if you didn't get one, it's okay. It's all good. So with the second one, do you agree? Yes, exactly. Wow. Yay! Now the third one. Cool. So here what I wanted you to again. Wait a second. Yeah, okay, it's okay. What I wanted you to figure out is that e is just a simple number. So the derivative of the numerator will be this thing, because it's like pi, right? It's a number. So it's a constant, and we consider it as it is, and we don't need to find an approximate values. We just say it's a number. Okay, great. And then the fourth one is like that. Okay, cool. And then the last one that I forgot, I mean not forgot, but I didn't have time to do it, so we can do it together. So that will be a fraction, and for sure the first thing I do as always is put in the denominator, raising it to the power of 2. Okay, now here I'm going to have the first derivative of the numerator, which will be 1 plus 1 over x. And then I multiply it by the denominator. And the denominator is this. And then I'm saying minus the derivative of the denominator is 5 plus 3x squared, and we do times the numerator, x plus logarithm of x. Okay, great. So we finished that, and Today, let me stop the recording first.